at the electrolysis of lead bromide. Lead bromide is an ionic compound. Nothing happens while the lead bromide is solid because the ions are in fixed positions, so they can't move. As soon as the lead bromide melts, the bulb lights up, showing electrons are flowing through it. The lead ions and the bromide ions in the molten liquid must be moving and carrying the current. The positive lead ions are attracted to the cathode, where they gain electrons, so they become lead metal. The negative bromide ions are attracted to the anode, where they lose electrons and form bromine gas. So let's sum up. The positive lead ions have gained electrons, so they've become reduced. The negative bromide ions have lost electrons, so they've become oxidized. We can represent these reactions as half equations. They're called half equations because each one is only half of the overall electrolysis process. One half equation takes place at the anode and the other takes place at the cathode. Remember, all half equations still need to be balanced in terms of atoms and charges, and the overall gain and loss of electrons must be matched. So, can you predict the products of the electrolytic decomposition of molten zinc chloride and potassium iodide? Let's see how you did. The electrolysis of zinc chloride gives zinc, which is a metal, and chlorine, which is a non-metal. The electrolysis of potassium iodide gives potassium, which is a metal, and iodine, which is a non-metal. Now this is going to be a little bit harder. Try and write the half equations for each of the compounds in the electrolysis reactions. So at the cathode, zinc is a metal, so therefore it gains electrons. It gains electrons, so therefore it is being reduced. At the anode, the chlorine loses electrons, so it is therefore oxidized. Let's take a look at what happens in the electrolysis of potassium iodide. The potassium is a metal, so it gains electrons. And at the anode, the iodine loses electrons, so is therefore oxidized.